The chapter of aerodynamics. Welcome. Aerodynamics is the study of the forces that affect a flight. Aerodynamics answers the questions like why does an airplane fly? How does an airplane turn? How does it climb or descend? Why does an airplane stall? What are the different factors that can affect an aircraft to be stable in the air? These are the questions that are answered by aerodynamics. Personally, I find aerodynamics a really interesting subject and it is one of my favorite things to teach. Let's get started. The four forces of flight. During flight, there are primarily four forces acting on an airplane, which is lift, weight, thrust, and drag. Lift is the upward acting force which is created by the flow of air over and under the wing. This is the force that supports the airplane in the air. Weight, on the other hand, is the downward acting force which opposes lift and is created because of the gravitational pull created by the earth. Then comes thrust. Thrust is the forward acting force created due to the movement of the propeller blades. That is the force that propels the airplane through the air. Opposite to thrust is drag. Drag opposes thrust and limits the airplane's speed in the air. During an unaccelerated straight and level flight, when the aircraft is not gaining or losing speed, nor it is climbing or descending or turning. In this condition of flight, all the forces of flight are said to be in a condition of equilibrium. Equilibrium means lift is equal to weight, thrust is equal to drag. It does not mean lift is equal to thrust is equal to weight is equal to drag. It only means that the opposing forces are equal. Now we will take a look at lift in detail. Lift. It is the force which opposes weight. Lift is the key aerodynamic force. It is the force which opposes weight. In straight and level flight, unaccelerated flight, when weight and lift are equal, an airplane neither climbs nor descends. It is in the state of equilibrium. The biggest challenge in making an airplane fly is weight, that is gravity. We have to create a force that is going to oppose and overcome the gravitational pull of the earth. And that is exactly what lift does. The wing moves through the air and produces lift which opposes weight. A wing is an airfoil. An airfoil is defined as any object that interacts with moving air or air and produces aerodynamic forces. In our case, the wing is the airfoil that interacts with moving air and produces the aerodynamic force of lift. We also have propeller blades, which are also an airfoil. The tail of the airplane is also an airfoil. All of these surfaces on the airplane create aerodynamic forces, which we'll cover throughout the chapter. Now, there are two main theories of lift production. We have tried to explain why does lift occur or how is it generated. The first theory is based on the Newton's third law. The Newton's third law states that for every action there is an equal and opposite reaction. We all might have heard this one. To understand how this creates lift, we need to take a look at the airflow around the wing. This is the image of the airfoil and its airflow. The leading edge, the trailing edge, air moves up and over as well as down and under the wing. The deflection of the oncoming airstream upwards is called upwash, and the downwash is the downward deflection of the airstream as it passes over the wing and past the trailing edge. This downwash is created due to the shape of the wing. The shape of the wing is made in such a way that it creates downwash. And downwash is nothing but the wing pushing the air downwards. Now, what did we learn? Newton's third law. Every action has equal and opposite reaction. So if the wing is pushing the air downwards, there will be an equal and opposite reaction from the air that is going to push the wing upwards. That is one of the theory of lift production. The second theory is the Bernoulli's principle. Take a look at this diagram. Bernoulli's principle states that as the velocity of moving fluid can be liquid or air or gas. As the velocity of moving fluid increases, the pressure within the fluid decreases. This principle explains what happens to air passing over the surface of the wing. A practical application of Bernoulli's principle is the Venturi tube. The Venturi tube has an air inlet that narrows to a throat, which is the constriction point, and then the outlet section, which increases in diameter towards the rear. Now, the diameter of the outlet is the same as that of the inlet. The mass of air entering the tube must exactly equal the mass exiting the tube. At the constriction, the speed must increase to allow the same amount of air to pass through the same amount of time as in all other parts of the tube. When the speed is increased, the pressure is observed to decrease at this point, and past the constriction, the airflow slows down again, just like it was before, and then the pressure increases. Now you might ask, Chintan, how does this affect the wing? If you look at the wing, the greater curvature on the upper portion of the airfoil causes air to accelerate as it passes over the wing. According to Bernoulli's principle, the increase in speed on the top of the wing is going to create a drop in pressure. And now we have a relatively lower pressure on the top and a relatively higher pressure on the bottom of the wing. This causes a pressure differential. Anything wants to go from high pressure to low pressure. So that is why there is an upward force created from the high pressure to the low pressure. And this upward force is the lift. This is the second theory of lift production. A wing is designed to use both of these factors, the Newton's third law and Bernoulli's principle.